Okay, so you should hear me now. Okay, yeah. So before we dropped off, we were working through several different bugs, and it was a little bit like whack-a-mole. But I think I've got a new game plan for how we can attack this after stopping and eating some food and playing with the internet for a little while. Yeah, so we're going to jump right back into that. I did have to reboot my computer while we were gone, so I am going to have to do setup again, but that's no problem because I can show you how I do that. So here we got desktop, and yeah, so what's up over here? So in CD Pi. So in my OpenMind directory, I've got kind of the main projects that I've been working on lately. I just go Jupyter Lab. So I'm a pretty big Jupyter Lab fan. It's a really convenient interface, and yeah, it just tends to work really well. So it pops over here, and then in Files, in PySift, Examples, Experimental, we were working with this federated learning example. And oh yeah, there's one piece of missing, which is chat, which I was going to pop out so that we can have a chat whenever. So how do I do that again? Oh yeah, down here, pop out. Not that you needed to see how that particular piece worked, but yeah, if you're hanging out and see something and have a question about it, just pop it into the chat, no big deal. And I will answer it as quickly as possible. Alright, so where were we? Let's go ahead and run. So we were in the process of constructing a unit test in torch test right here, which is down here at the bottom. And the surprising thing was we were still having an issue with registration for model.grad.owners. So we can go ahead and rebuild this just to sort of see what that error was like. We're going to get this variable object has no attribute owners issue, which if you were watching the previous video, this was something that was quite prolific. And we thought we had gotten almost all the way to the end of it. Yep, so we're back to there. And in order to be able to... So basically, what's happening here is that variable is creating a new gradient object at some point, you know, when we call it backward. But parts of that object, the gradient specifically, are not getting registered, meaning our hook is not learning about them. And so what that means is, when we go down here, we can see exact example. Boom. Variable object has no attribute owners. Now, registering is not difficult. It just needs to be done. And since apparently no code that we've written has really interacted with this yet, or the Python object for grad got recreated again at some point. Yeah. So the interesting thing here is model.grad backup does exist, and it does have owners. Huh. What this means is that grad has been registered, but PyTorch destroyed the Python object and created a new one before we got to it, which, to be honest, is kind of annoying. However, the interesting thing here is that what if we created a backup owners? Is that cheating? So the technique that we had previously, the grad entirely was not getting kept or registered, but now we're just losing attributes on grad. What was the thing that Jason was talking about earlier? Where were we working? grad backup, grad backup. Oh, here we go. This is going to sound a little bit funny, but what if we did self.grad.backup dot no, because it still has a reference to it. So previously, grad was getting deleted entirely, and now we're still able to keep a reference to grad, but we're losing attributes of grad. So the question is, what are we going to do about that? We have a few options. My least favorite option is to actually turn this into something that actually runs a function, so that if this attribute isn't here, then it will actually look for it elsewhere. Yeah, not my favorite thing, but it could work. And the crazy part is that when we run this, this gets registered. So all we really need is for registration to get called on this. Fascinating. Oh, that would. Ooh, something just happened. Printing grad backup. Ah, so grad backup doesn't have owners either. Haha. This might work. Gonna be a little bit surprised if this works. Oh. Be a little surprised if it's that simple. So basically what I'm trying to do is figure out how we can keep around the right references so that PyTorch doesn't delete things that it should keep. That's surprising. right. Okay, so at this point, because gradients are a little bit of a special case, I'm going to treat them like a special case, and I'm going to replace owners with a kind of function. It's not my favorite. Yeah, it's not my favorite thing, but I think a lot of this complexity is going to go away when PyTorch 1.0 comes out. And so this is a little bit of a workaround until we get there. I'm trying to remember how we do this. Hopefully this yeah, so what I'm trying to remember now is how we can do an attribute that actually runs a function, so that when we say, you know, model.owners, it actually runs a function that goes and tries to calculate how, you know, who the owners are. Just so we can bake a little extra logic in there. If anyone listening remembers how to do this, that would be an awesome tip. I'm just trying to remember exactly. I've done this before. What I'm trying to do is I'm trying to make it so that when I go, okay, so class something def init self def, you know, objects self return my objects. What I want to be able to do is I want to go x equals some class, and then I'm going to go x objects. I don't want it to return bound method. I want it to actually run the method and return the output, right? So that it feels like food at fish. There you go. Oh, cool. Just this little property flag. Boom! I knew it was simple. Cool. So let's make that a property. Cool, so up in Okay, so for variable, we're going to say override objects. So hook var objects. Python object, Python property get set. So we want to do a getter and a setter. Perfect. Oh, that's gorgeous. And I assume we need to call this objects. Oh, owners. Silly me. Okay. Self.owners. And then cool. Might work. I guess the first thing we should do is just activate it and see if it breaks anything. Ooh, it did break some things. Oh, it broke a lot of things. Oh, accidentally said objects again. Here we go. Try this again. Okay, test pass. Awesome. Now we should see something called underscore owners. Sweet. Okay, cool, perfect. So now we have a function called owners that when we call, so var object has no attribute underscore owners. So it's actually calling this, and now that we know that it doesn't have that attribute, we can try to override it and basically go find it somewhere, right? Like call register object or something like that. Yeah, this could work. If has at her self owners, return that. Else, let's see. Okay. So we want to do else. So either way it's going to return self.owners, but if self.owners doesn't exist, we want it to register it. Which means we want to call hook self.local worker dot register object hook self.local. Sure, yeah, that'd be killer, thank you. Hook self. No, it'll be okay, thank you. Aw, that's great. Thank you very much. Worker equals, and then I'm reading down here, so object equals self. Let's try that. Oops, typo. Just checking, make sure the internet connection is still good. Okay. Let's see what happens. Look at that. Okay. Now, I'm not totally convinced that that will work for all use cases. It will work for all use cases other than there's occasional reasons why that might fail for virtual workers. I'm trying to figure out how I would test that. Also, there might be a reason to do this with ID as well. Seems to be working great though. Okay, well, so I think this is going to work also for anything socket based. So basically the real question is, how does it know what owner to assign, like this local worker? And the default, if it hasn't been told to be assigned to someone else, is to assign to whichever one is assigned as the local worker, meaning it was initialized with the hook itself, which is the one that we have access to here. So it's theoretically possible that if this gradient was created, do grads have pointers to their parents? Huh. Oh, doesn't mean pointer network does not help me. PyTorch rad variable. Let's just see if we get PyTorch docs. Oh, this should work. Okay, need to go back to different version, 0.3.1, because all the mine's, PySif right now is compatible with 0.3.1. Grad variable. Another way we might be able to solve this would be with a register hook. I don't think we need to. Let's stick with this for now. Well, actually, let's see if the rest of our unit test works first. Looks like it works. Cool. Okay. Time to do some cleanup. Got a lot of print statements, so we need to get rid of those. Here we go. This is a doozy of a bug day, and we discovered a couple others along the way. Always fun. Okay, just make sure I didn't accidentally delete something I needed. All the tests still passed. Very good. Okay, so it looks like we're still printing. Okay, there is a gradient. Where is... Aha. See any more print statements? Okay. Let's try that. So I'm just looking to clean up print statements at this point. Ooh, still got some more. Tracking down old print statements can be tough. Okay, get rid of these guys entirely. Oh, here we go. Okay, I think that was all the ones in hooks.py, which is a good percentage of the code base. It's the only one in Twitch test. Let's see. Beautiful. Awesome. Let's reload this. That is just fantastic. Ah, that's great. That is really something. Oh yeah, we were going to add this check too. Did we add that test already? We did. Oh, in remote objects. Cool. So we should be able to more or less replicate these. Let's try to rebuild that. This was just checking to make sure that all the tensors that were supposed to get sent did get sent. Oh, not owners. What a goofball. We just want the ID itself. Cool, let's try it again. Beautiful. Okay, so doing a little bit of logging here. Awesome. Model and all children are owned by the local worker. Perfect. It's a good unit test right there. Love it. Awesome. So this was actually a huge tangent from working on federated learning because we ran into more or less a bug. So now I'm going to go ahead and do a git commit fixed issue 1350. I don't think we had to add anything. Oh, good to add the notebook. Notebook's an experiment, so feel free to push. I'm not rigid about notebooks that are in the experiments folder. Okay. So let's see. Now if we go to PySift, actually get that link. Compare and pull request. Okay, fixes issue number 1550. In this PR, we fixed multiple bugs regarding variable and child gradient registration. filling out the PR correctly. Let's see, this has been tested with 2 unit tests. So the first, whoa, did not want to save that. Let's see, is test torch variable. So test.core.torch test dot test torch variable dot which passes, and B, which has the same general path except for the end, which is this guy. Oh, did not fix style guideline issues, so we'll leave that on comment. I have reviewed, I have commented, there were no documentation changes needed, no new warnings, once I fix those style guidelines. Yep. Great pull request. Okay, so we still need to fix these style issues. Whew, we created a bunch of issues. Okay, oh, one of these guys again. I really should get an automatic linter. Okay. Oh, I'll just copy paste these. Okay. Whoa. Not exactly what I meant to do. Okay. Only a couple style things. Okay, no big deal. Local variable underscore is assigned but never used. 536 in workers. I remember writing this. This is when we had to check see if object data is in there. Just a style. Trailing white space, 526. There's a way to override that, but I don't want to have to look it up right now. Oh. Missing white space. Right. Okay, and that's all for workers. So we got a couple things in hooks.py. It's up here. So hooks.py 990. I don't know how much you guys enjoy watching style fixes issues. I really should just write more stylish code, but such is life. Blank line contains white space. Hooks 990. Oh, this guy. 912. Trailing white space. Just gotta do that good old cleanup, man. 814. Missing white space after comma. Yep, remember writing that. 695. Too long. Oh yeah. Weird. Fixed that one yesterday. I think it has to be like that. Yeah, pretty sure that's right. We'll see if it goes blank line to end of file. Oh, that was all of hooks. Now torch test. Okay. Merge test. Too many blank lines at 175. 166 is trailing white space. .152 missing white space after comma. Missed one. Workers dot. Oh, that should be all. Hopefully it's all of them. I really should fix those style issues as we go. Ooh. 537 workers.py. Oh, before inline comment. There we go. It's like, it got worse. I want it to get better. Alright, got all those style issues fixed. Perfect. Fixes. Git push. Okay, should update. Ooh, conflicting files. Oh, something merged recently? Merge conflict. Okay. Show me the merge conflict. Oh, there we go. Yep. This is something that we fixed yesterday, so if you saw the video yesterday, you'll remember installing this. So, just looked like the master didn't have it. Oh, I really should build and test again. Merge already showed up. Man, GitHub is so well made. Extraordinary website. Not sure how I feel about it being owned by Microsoft now, but you know, it's all good. Oh, create a style issue. Where'd all these style issues come from? Ugh, goodness. Okay, 153 workers.py. How did these get into master? Oh, this is an NPC merge. These aren't supposed to get into master. I don't think I'll figure out what happened there. Those are just comments that are too long. Ooh. Little things like that can be kind of annoying. Cool. Let's see if we're close. Oh, we are close. Workers.py 206. And oh, that's it. Okay, let's try that. Cool. Alright, style fix. Git push. Alrighty. Travis is going to build, but I already built it locally, so I'm going to be happy to merge it. Confirm merge. Okay. I want to see what's. Okay. Awesome. And this. can close with merge PR. Man, GitHub is awesome. Look at that. Look at that integration right there. That is beautiful. All right, close another issue. Ballin'. All right, now. It's like the biggest where were we of my life? We were working on getting oh yeah, if you're ever interested in seeing kind of what code gets finished here, there's this channel in our Slack which every time a PR is merged, someone comments on an issue or something like that, it gets pushed in this code. So it's hooked up with GitHub, and it's a great way to stay up to date on what's happening in the project. But yeah, it's pretty good. Okay, let's see here. Where was I? I was working on federated learning. Let's get back to that. Whoop. All right, so what we were working with was this guy right here. That's not right. Cool. So, federated learning, for those of you who weren't here 4 videos ago when we were still working on it and didn't get sidetracked working on bugs. I guess 3 videos ago. Actually, let me make sure the video is still going. Cool. Yep. Every once in a while I have an internet hiccup and then videos get squished away. Alright, so let's just reload this. So this is hooking and creating a remote worker, creating our data set and our model, and then yeah, let's do this all outside the for loop. So this is prediction. And then, ooh, we might be able to use an optimizer. That'd be cool. Oh. So we're going to use the stochastic gradient to send optimizer. And we're going to say, so what's the loss? We're going to say optimizer step. Okay, and we predict again. Loss goes down. Love it. Okay, so now the question is, if we take all of these and we say data.send remote target.send remote model dot weight dot remote model dot bias dot send remote, can we still do the same thing? Okay, backpropagation works. Loss.kit. Okay, so 1.113. Oh, the loss doesn't change. Womp womp. Okay. So the optimizer is not happy. But the optimizer is written a little bit of a funny way. There's a try catch in there, I'm pretty sure, that deals with something. We won't worry about it for now. But let's do stochastic gradient descent by hand, or at least attempt to. So we have model dot weight dot data. Model.weight.grad we don't know about yet. Oh, that's right. That's how we got into this. Okay, so let's create the gradient before we actually send it over. And the way we do that is we actually run a prediction first. Okay, now let's try this again. Actually, let's go for the optimizer again too. Okay, loss.kit op.step and predict. Look at that! The optimizer works! Oh, that's so cool! Oh man, that's awesome. I love that. Okay, what about model.grad or model.zero grad, and then so if I do run model.zero grad, and then I go model.weight.data, grad .get. It's zeros! Zero grad works. So I didn't think this function worked yesterday. Oh, this is so great. This is so cool. Okay, man, federated learning is totally gonna work. Oh, with the optimizer too. Oh man, I'm so excited. This is so cool. Oh man, this is gonna be awesome. I mean, yeah, we have to do some special things to make it work in PyTorch, but oh man, this is cool. I'm a big fan of this. I would like to actually let Jason know that I am working on this one. In the off chance you're not already here, Jason, totally about to get PyTorch up and running. On issue 13, is it 50? Assuming I don't run into another bug, which is certainly possible. Okay. Oh yeah, 1350. It was 1350. Hey, what's up? All right, so let's see. Let's get this running in a for loop. So this is remote training, which is super duper cool. So what's happening is right here, we create our data set. Here, create our model. And then right here, we're doing a prediction, creating our gradient objects. And there's not that much of a, that's so cool. I wonder if that's possible. I just thought of a way we might be able to get around this. Well, we'll let it for now. So basically, when we move tensors to a remote machine, some tips to learn Java. Yeah, I learned Java not too long ago. There's a really good IDE. So I learned Java inside of this IDE, which you might like, because it helps you do, if you're not familiar with object-oriented programming, it can be kind of nice. And then I would definitely recommend Manning Publishers Java. So Manning Publications here, they do lots of really good books. Let me find a specific one for you. Yeah, this one's going to be really good. So Java in Action. And so I'm an author at Manning as well. So check out this and try the coupon code TRASK40. I'm pretty sure that gets you a discount on any Manning book. It's like a 40% discount or something like that. So if you went for the ebook, you could get this for 43.99 times 0.6 for 25 bucks. And it's great, and I highly recommend checking out. There's a good chance this will actually use BlueJ, the IDE I just showed you. But yeah, if you want to learn Java, check that out. It's really good. And oh yeah, actually you can get chapter 1 for free, looks like. just to see if you want to try it out. So here you go. Best of luck in your Java learnings. Yeah, sure thing. Okay, back to federated learning. So reboot here. And then move our tensors. And then this is going to be our learning, and then loss.get.data 0 for I in range 10. Come on. Come on. Oh, I forgot to print it. That's funny. Oh, that's so good. Yes. Oh, that's awesome. Federated learning, here we come. Oh man, this is great. So what's happening right here is we're training a neural network, but it's on a remote machine, and we're using a JSON interface to actually communicate with it. But notice all this still looks and feels just like PyTorch. Now let me try to remember. I think this didn't work yesterday, but it might have been a different kind of error. So loss equals criterion pred target. Okay, yeah. Variable object has no attribute is pointer. I'm not entirely sure why this loss didn't work, but I'm also not too worried about it. There's going to be a few things that we're going to have to kind of rework with simpler tools than what is available in PyTorch, and loss functions, and then special things like convnets or conv layers we're also going to have to do. So I'm just not too worried about it. Okay, so what I would like to do here is now say, what if we have two different data sets on two different machines? So let's duplicate this. Data A, target A. Actually, data target. Data A equals data 0, 2, target A. So we're going to have user A and user B, or remote A and remote B. Equals data to the end. Whoa, target 0 to 2. And then data B equals data 2 to the end. Target B equals target 2 to the end. Okay, and then we need two remotes. So let's say remote A equals virtual worker. Remote B equals virtual worker with ID 2. Local.add worker. Remote A. Remote B. Let's reboot, just to be safe. Okay, we create our initial data set. This is just our task. Like, this could be any data set, right? And now we're going to split it into two people. And data A, let's see here. Yeah, so this is person A. We could have said Bob and Alice. Bob and Alice is a little more fun. Now I'll do A and B. Well, Bob, Alice. We'll do the standard cryptography ones. Bob, Alice. Let's say Andrew. Me. Yeah, well, let's make it more intuitive. Okay. This shouldn't be capitalized. I don't know. See, I want this to turn into some sort of tutorial or blog post or something. So I'm inclined to try to make it a little cleaner right here in the beginning. Okay, data target, data Bob, target Bob, Bob data. Bob target. We'll do data Bob, target Bob. And then data Alice. Okay. And now, so we split our data. And we send that data to Alice and Bob. So actually we can do that up here. Dot send Alice. Send, oh, Bob. Bob. Send Alice. Dot send Alice. Oh. One little bug fix. Yeah. Yeah, let's do it. Here we go. I like using send without the underscore. I know there's sort of a stigma for inline versus not inline, but we don't have not inline versions, so you know, we'll get there. Sorry, typo. Awesome. Okay, let's reboot. Okay, awesome. Let's see. So now we're going to create a model, and we're going to initialize the gradients. Not because we need to, but just because. Not for any really good reason. Okay, model up parameters. Okay, now here's what we're going to do. The first thing we're going to do is we're going to send the model. Send model to Bob. So model dot. Ooh, we could implement a send function for model. Because technically it's like get parameters and then send all the parameters. We could do a for loop here. So what we need to do is waits dot data dot send Bob. Model dot. Actually no, just wait dot send model dot bias dot send Bob. And then do one iteration. What happened? Oh, data Bob. Oh, yeah, data Bob. And target Bob. Argument out of range. That's odd. Oh, there we go. Okay. And then what we're going to do is we're going to pull the model back. So we're going to say model.weight.get and model.bias.get. And model. And then we're going to do basically repeat the same thing with Alice. Oh man, this is great. So Bob has updated the model, and then we got the model back. So send the model to Bob, update the model, get model back from Bob. And that was Bob's loss function. So we can actually repeat this Oh. Maybe we couldn't repeat this over and over again. Looks like we have some sort of registration error again. Let's see. Let's try this again. Let's just try sending and receiving the model a few times. Get model.bias.get. Wow, okay. Well, here we go. We have another small error. Wow, we're so close. Ugh. Variable object has no attribute ID. Oh, it's asking for the grad ID. In workers. In register object. So the grad has not been registered yet. Interesting. Let's check it out. Workers.py, line 627. Workers.py, line 627. Okay, here we go. So we have a grad object, but surprisingly, that object does not have an ID. Why would we have a grad object without that grad having an ID? So this object was likely recently initialized. This is in probably get. Where is this? Hooks.py, line 717. Aha. So this register object. Fascinating. Another interesting thing here is that this is registering objects recursively when we actually just spent the last several hours working to not have to do that. Like, notice how this first registers the object, then wait, what line did this fail at? $7.17. Wow. So 717 is definitely doing the work of these as well, because it does it all recursively. So I think we can go ahead and comment this out. I don't have a reason to think that this will actually fix it. But yeah, I don't think this will actually fix it. But I'll be curious to know if it breaks it. It does break it. But it only breaks it in one spot, which is the remote backpropagation. Ah, I see. Now it is a curious thing. So register object we recently changed to be recursive, meaning register object will automatically go in. But it might not necessarily set self.data. So we still have to go self.data equals x.data and self. And if x.grad is not none, self.grad equals x.grad. Because you're passing in x dot stuff, and then we're setting it to be self. Boom. Okay, cool. So it's interesting that we can get rid of that. I like that we can get rid of that. Let's see what it does over here. It probably won't change anything. Just a little bit of cleanup. Yep, still nothing. Okay. Variable object has no attribute ID. Now the real bummer is that ID is a really hard thing to restore, right? I mean, if you for owners, we can like set it to be a default or something like that. But it's difficult to find the ID. But what we can do is use a try except here to sort of poke around. I think there's a Python test suite, a Python debugger that you can use in Jupyter. That would be really cool. No way. What? Okay, we're gonna try this out. If this is true, this might say like change my life. Okay. Wow. Huh. There's a Python at exception. Oh, PV post-mortem. That's it. Sorry, I'm just doing a little bit of general learning here. Post-mortem. Alright, let's do it the old-fashioned way. Which, I really should spend less time putting in print statements and then trying to figure our way out. More time doing stuff like this. Maybe it'll work. I want to turn off tests for that. Wonder if it will do it here. Haha! Ah, cool. A debugger inside of Jupyter. Okay, so what are we looking at here? So ID. There's some config where we can actually say, so okay. So we were at ID. So one thing we're curious about is x. x.id. x.grad.id. x.data.id? Wow. Well, what was our error again? It was x dot. Wow. x.grad seems to have an ID. Ah, I registered it. That's why. And there's no guaranteeing that it's actually keeping the same ID, is there? But you know, when I call get, I think I have the IDs of all these things before we start. So that's something. You know what? Get should actually be a recursive call now that I think about it. Like, and it should be depth first. Like, So if the ID is already there, where did it go? It could be that I accidentally registered it. So let's try that again. Continue, continue. And then okay, so okay, there's no need for us to be doing this twice. So we can just say cool. That should work nicely. It's really this last get that breaks it, I'm pretty sure. Just so we know to have the debugger keep going past it. Continue. Okay. So got the debugger working. Okay. Okay, now get. I ran the wrong one. My bad. Continue, and then right here. Okay, x.grab.id. Object.grab.id. I swear, it got replaced. It was totally there just a few seconds ago. How strange. Okay, well, we have ourselves a proper mystery here. What are we going to do about it? So somewhere in here, let's go immediately, actually, x.grad.id seems to be here. Let's hop here. So it fails in line. Workers.py 627. Workers.py 627. Which is here. Register object. Which means it fails here instead of this register object, which means we want to set this right here. And just for the sake of argument, continue. Okay. Oh. Well, that's surprising. Must be down there. Did not expect that. Oh wait, I did know that. Okay. Let's try it down here instead. Continue, continue, continue. Awesome. Continue. Okay. x.grad.id. Continue. Okay. We need to set man. We need to step into there. So let's try this again. $721. Whoa. That's weird. The debugger kind of skipped it. Let's do a print statement instead. Hooks 721. Gosh, we said right there, but it went. Maybe I was using the debugger incorrectly. Very curious. The debugger is not really helping me much. Either that or, oh, no, it's not accidentally registering anything because oh. Okay, let's try putting it immediately before when it's supposed to break, which was wait a minute. This is a different place. Oh, I'm just having to step so far. $6.27. Okay. Oh yeah, that is the issue. See, object.grad.id. Continue. Here we go. Okay, variable object has no attribute ID. So object does have that. So object.owners. So object.hook dot local worker. Object dot. How does object not have a Does hook exist? Hook does not exist. What all do we have in here? What is self? Ah, here we go. Okay, so self is the worker. So self dot objects. I think the gradient already exists, but the problem is, ooh, let's look for a backup gradient. Self, so object backup grad. Grad backup dot ID. Well, would you look at that? That would be the correct ID there, sir. So object.grad.id is nothing. Object.grad.id backup.id is that? Slimy little bugger. What if there's a way to make it so that grad has a pointer to its parent as well? That way, if it needs to bail out and find missing attributes like this, it can. Without having to do something like re-register, which would be a real pain. Seems plausible to me. Let's see. Going to pause real quick. Just check this message from Bobby. Be right back. Okay, where were we? So the idea here was we actually have a backup ID. But for some reason, regular grad is getting lost. What if we actually change this to backup grad? Not my favorite. Okay, I say that for every gradient we actually give it a pointer to its parent as well. Yeah. Hooks. So, contents. So hook new grad. Self dot grad dot parent equals self. Dot grad backup dot parent equals self. So one of the big difficulties here is that PyTorch can remove Python objects occasionally. So if you haven't explained this before, yeah. So what we're doing is we're basically doing backup references so that doesn't happen. And then we're going to do we're going to change ID to be a property, just like object, or just like owners, excuse me. Var properties. Def ID self if return self.id else self.id equals self.id. Parent dot yeah, I think this works. Although if it doesn't have an ID, it probably won't have. Let's not do this part yet. Okay, here we go. Okay, I'm going to actually stop running unit tests for a bit because they are cramping my style with this debugger. And here we go. Wee bit faster. Waiting for the notebook to reload. Here we go. Okay. Oh. Whoops. Wait for the debugger to reload again. Okay. Just gonna get resituated here. Alright. Variable object has no attribute ID. On the first send, something I did broke this. Okay, let's try that. So, surprisingly enough, $624. Huh. Send breaks as a result of having the parent refer to itself. Super strange. So I suppose that's not going to be an option. Oh wait, never mind. Gotta keep going. There's something else. Well, could be that we needed that. For some reason I didn't think we needed that. It's possible though. We did need that. Oh yeah, I guess I learned that earlier. Okay, so we can still try self.grad.parent equals self, self.grad backup.parent equals self. I'm quite hopeful that this works. The recovery method to try to figure out where the objects went would be really nice. Gotta get through all these. Okay, here we go. So it was 1, 2, 3. And then did not expect it to just solve it. Fascinating. Okay. Man, garbage collection logic is some mysterious juju magumbo. Well, would you look at that? It works repeatedly. All right. Small bug fix for garbage collection. I think we might have still had a commented out debugger line around here somewhere. Yeah, there we go. Okay. Okay, Python setup test by test. Let's just make sure all our unit tests still pass. Well, how about that? All right, back to our federated learning demo. So this was sending the model to Bob. Man, that's so cool. I've still got a print statement in here somewhere. Oh no, it's just the... Oh goodness, that's so cool. Okay, so yeah, federated learning. Where were we? So the idea here is that the model gets sent to Bob, the model gets updated, and the model comes back from Bob. Then we can do the same thing with Alice. So now we'll send it to Alice. Data Alice. And we'll get it back from Alice. And then we'll send it to Bob. And then we'll send it to Alice. And over time, the model will eventually learn to be good at both Bob and Alice's data. Ladies and gentlemen, basic federated learning now works with PyTorch and PySift. However, it's kind of ugly, and you sort of have to know how to do it. So yeah, all two of you who are here, this was like a really big thing for this project to reach. You may or may not know that, but that's okay. Let's see, I don't even know. Yeah. How about that? Okay, so what we'd like to do is, at least what I think we'd like to do, is create a new type of optimizer that is sort of built for federated learning. The idea being that you can pass in a series of target and of input and output targets, and this thing will automatically move the weights there. Actually, now that I think about it, we'll need more than an optimizer to be able to do that. Yeah, so what we want to be able to do is basically make it so that we don't have to have all this boilerplate. So parts we want to get rid of. We want to get rid of this part, so we want that to go away. We want to get rid of explicitly having to send and receive from specific people. Like, it would be really nice if we just had like a combo data set. Yeah, that would handle a lot of this for us. It's super cool that stochastic gradient descent works right out of the box. I'm really excited about that. Yeah, that's pretty stinking cool. All right, so actually I'm going to take a quick break, and we'll pick up in maybe 5 to 10 minutes. See you. All right, cool. So where we just left off is a super exciting part where we got federated learning to more or less work. But at this point, it's just too wordy. So what we want to do is simplify this and make it, easier to use. The thing I have my eyes on first are these individual parameter send and receive calls. So it would be really nice if we could collapse this to just be model.send Bob, right, as opposed to each of these individual. And so I think that we can actually do this pretty easily by overriding inin.module. So what we're going to do is we're going to set the attribute of inin.module to do something like model.parameters. Let's see. mp.send Bob for p in model parameters. P dot send Bob. Doesn't have to be a one-liner. 4p model parameters p dot send Bob. Right. So the idea here is that and then 4p p dot get. Probably called send too many times. Okay, here we go. Let's try this again. And then do this with Alice. So the idea here being that so we can iterate just through all the parameters, and instead of actually doing this for loop, we can just override or really extend inin.module with this ability. So we can create a function. So inin.module.send equals so def module send destination and yeah, equals module send. And now, hopefully, we can just go model dot send Bob. Oh, whoops. Boom. And let's do one for get as well. Oh. Accidentally called it too many times. Man, you really can't get out of sync with this thing. Amazing. Love it. And it works. let's ooh, that's surprising. Oh, dest. And there we go. Just like that. Cool. So this seems to be working okay. Now let's go ahead and install this code into Torch Hook. Let's see, hook get, where should we? Hook module self. And then in the constructor, we call it so that it actually overrides it. All right, and that should do it. Simplifying this code already. It's right here. Oh, that just runs test. Okay, let's rebuild. Okay, let's try it out. Ah, this should be self. Boom. Just like that. That is awesome. Okay. Now, let's see here. What is something else that we can do? I wonder if it's possible for us to actually get rid of this model.send so that when we actually call a model, if it's not on the correct, if the data is not on the correct machine, it would go ahead and move it there. That kind of convenience item is really nice. But we would also need it for this subtraction here, which means on every single overload we would need to check to see if the two operators being used are on the same machine. And if one of them wasn't, we would have to choose which one to send it to, and it's actually not clear which one is right? Should we call target Bob here or send pred there? So it's probably better for people to actually be explicit about these kinds of things. So yeah, okay. What about this whole generate gradient thing? Ooh, send could check to see if each parameter already has a gradient or not, and if it doesn't, it could generate one. If it doesn't, it could generate one and then zero it out. That works great. Okay, so how would we do that? Let's just write a function that checks to see if model has a gradient. For all parameters. Model dot weight dot grad. For p in model dot parameters, if see missing grad equals false, p dot grad is none, missing grad equals true. Def check model for grad objects. So the idea here is that we showed earlier, I don't know if you were all here earlier, but we showed earlier that if we initialize a gradient on a remote machine, then we have no way to know that we should have a hook to it ahead of time. So we need to create our objects, at least the memory, before we send it over there so that we have a hook. There might be fancier ways to do this in the future, but for now, this is like a reasonable way. So missing grad, okay, it is missing a grad. This, missing grad equals false. Perfect, it works. Okay, so now if we are missing a gradient, what is a sort of easy shape agnostic way to initialize gradients? So for p in params, model params, p, see, o equals p plus p. Oh, now let's do p dot sum o dot backward. Now they all have gradients, but those gradients are probably not zero. O p dot grad. Yeah, they're. And then p minus equals p dot p dot grad. And now they're zero. Perfect. Def create gradients. Grad objects for model. Okay, so now we just need to throw this into the model send. So let's see. Okay, if self, ooh. So if module is model is missing grad, or module is missing grad, create grad objects model. Perfect. And this should make it so that we don't have to worry about the module not having gradients. Which means that we can, in theory, skip this part. Ooh. create grad objects self. Create grad objects self. One more time. Amazing. Amazing. It's getting simpler already. Matter of fact, that's about as simple as I would like for it to get in terms of hand coding. The only thing that could be nicer is if we actually had something that would iterate automatically. Golly, actually, this really isn't that bad. So data sets, data Bob, target Bob, data Alice, target Alice. Let's see, 4. Target in data sets. Come on, let's send data.owners. Data target get for error in range 100. Wow. Cool. This is really cool. I can't believe this works, and it works with stochastic gradient descent. Neat. Okay. Basic federated learning example. I love it. Simple linear model using stochastic gradient descent across a toy data set owned with 2 different owners. In no cases the owners required to send their data. See. Alice and Bob. And just like that, federated learning works. Let's see what kind of style guidelines we might have. So, CD, say move examples, experimental, federated learning example, 2 examples. So we'll move this away from out of the experimental learning folder. And then files and examples. Rename. As that was named incorrectly. Okay, now let's clean and build and see how we're doing. So we want to turn back on setup.py.test. Okay, so our unit test pass, we got a couple style issues. So one, it looks like they're all in hooks. So hooks, man, hooks is getting long. 1015. Oh, 2 lines. So we see the comma there. Okay, what else? 1111. 1104. 703. Let's try building it again. Awesome. Style fixes finished. Git commit am. Style fixes. Okay, now one thing we haven't done yet is a unit test. So we should hop down to, we'll do it here for now. Let's see, torch test. Def test. Federated. Learning. Okay, now let's get this notebook and build a unit test around it. And I'll basically just say that like the model has to learn, right? So we're going to say if error equals 0, first loss equals loss.get, assert loss.get.data 0 is less than first loss. We'll do 3 iterations. Let's try to build it. Probably up. Oh goodness. Oh, in is not defined. 275. Blank line at the end of oh. Okay, missing white space after comma and 260. Ah, missed one. 236. 235. That's it. Cool. Oh, forgot to initialize torch hook with verbose equals false. Dot verbose equals false. Verbose equals false. Verbose equals false. Awesome. Okay, so let's create a Collab example so that people can run this federated learning demo on Collab. Let's see. Let's first go over here and merge this so that we can actually import it into Collab. See, compare and pull request. Let me find the video for this. So, no, that's not what I wanted. I wanted dashboard, video producer. Is that the one I'm in right now? No. How do I get the exact link for this particular video? Oh, what I need. Hey, sorry if I just saw your message. I'm using Sublime Text 2 for the code editing, and I'm using Jupyter Lab for the experimentation. I really like Jupyter Lab. Hopefully you're still here, Bri. Okay, I'm looking for... Yeah, I wanted to figure out what... Settings? Pop out player? No, that's not gonna work. How do I find... Maybe if I go in here. Aha. I don't want to embed an iframe. I just want to get the link. I'll get the link. Oh well, I'll add that later. No big deal. Okay. So it didn't fix a particular issue, but it is a new feature. And man, I am so excited about getting federated learning working in the system. This has been a long time coming. Actually, so I don't know that what I did requires a documentation update. I think later tests or later sort of abstractions or convenience functions or something like that. Okay, test federated learning was the unit test that we passed, and it does pass. What was the class path for that? So it is test torch variable, and then before that, that's probably sufficient. Okay, Mac OS X is High Sierra. Not available. 0.1, not available, not available. And yep. Gorgeous. Love it. And merge. And just like that, federated learning. So really, it's not totally clear where we should go next with this. Probably some, I guess we can go for more complicated layers, right? So this is using a simple linear layer. I imagine we'd probably run into troubles if we threw a convnet at it, or things, or tried to run it on a GPU foreign. Also, we're getting a lot of latency right now, so the performance of this could really be optimized. But yeah, you know, the basics are working, and I'm super excited about that. So maybe trying it in this demo with a multi-layer perceptron, getting a convnet working would be really cool. And yeah, but yeah, I'll leave that for another video. Until then, I'm going to tune out and then make a few announcements in the Slack for people to be able to try out the demo. But I hope you enjoyed this video so far. See you later.